So we're starting with long division. We talked a little bit about the vocabulary. Dividend, what we divide into. Divisor, what we divide by. Quotient is our answer. All right, so what happens is this divisor part goes out here. What we divide by goes out there. What we divide into goes under here. And then we start the process of long division. So the process of long division with polynomials follows the same procedure as it did when we just did numbers. All right, so let's do some numbers to remind ourselves. Let's do 7, 8, 6. All right. Now, remember when we did long division, you would say 3 goes into 7. How many times? 2. And then you would multiply, and then you would subtract. And then you would bring down. And then you would say 3 goes into 18 6 times. Then you would multiply. Then you would subtract. Oh, we got nothing this time. Then you would bring down. And then we'd say 3 goes into 6 2 times. And then we would multiply. And then we would subtract. And we get 0, which tells us this one has no remainder. If we got a number right here, we would have a remainder. Yes, Cole?
So we do have remainders now.
We can.
Okay.
Sometimes we will, sometimes we won't. And we'll talk about what having no remainder means. All right, so same idea, except I'm not fond of dividing. I like multiplying much better. So what I do is I go, all right, what do I have to multiply this leading one right here to turn it into that? What would you multiply x by to make 3x cubed? 3x squared. Okay, so that's what I get right here. Now you're going to watch me. Because it's 3x squared, I'm going to line it up right on top of the x squared. Keeping it lined up is very helpful. It helps you to be accurate. All right, so now remember down here, once we got that 2, we multiplied and put it right there. Same process. We have to multiply 3x squared times x minus 2. We have to multiply this times this. You got it. Multiply both of them. You have to distribute through. 3x squared times x is 3x cubed. 3x squared times a negative 2 is negative 6x squared. Okay, now, next over here, every time we subtract it, right? Same process. Now we have to subtract. And when we subtract, it changes all of our signs. You may even want to use a highlighter or a different color or something to remind you. You are subtracting, so it changes your signs. Oh, now this one's cool. What happens here?
0.
What happens here?
0.
So we bring the next one down. Yes, ma'am.
When you change the signs, you just change the signs at the bottom.
Correct. Because we're subtracting this binomial from this. So we're just changing the signs of this one. All right, so now we got to go through it again. So this is what we got now, 5x. What do we multiply x by to get 5x? 5. So we need a 5 up here. All right, so 5 times x minus 2. What does that give me? It gives me 5x minus 10. So here I have a 5x and a minus 10. So this time I actually need to bring down that negative 1 also, don't I? So it lines up. We always got to keep it lined up. All right, so now we subtract. And when we subtract, it changes the signs. The 5x's cancel, but this leaves me with a 9. I didn't get a 0. I got a 9. So that 9 is the remainder. Now, when we have a remainder, we take the remainder and write it over the divisor. So our answer is going to look like this, guys. Our answer is this quotient part, 3x squared plus 5. And then what we do is we take our remainder and put it over the divisor. And that's our answer. It will, which means I won't give you very many. So if you're doing a test on this, you're probably going to have one that you have to do with long division. Because you're right, long division takes a while. Which is why it's really nice to have that shortcut, synthetic division.
So when is our next one?
In here, okay, so I haven't updated the support calendar, but I did update the Algebra 2 calendar. I'll get the support next. So, whoops, that's pre-calculus. You guys don't want to do any pre-calculus, do you?
No.
Okay. All right, so here's Algebra 2. This unit is the second part of Unit 1. What we're starting today is the second part of Unit 1. So it's kind of shorter. It's 2.5 weeks. Now, we should have a quiz on this Friday, but what is that Friday? Homecoming pep rally day. So, because I know it's going to be crazy, and classes are going to be short, and in the afternoon, we're going to lose all the cheerleaders early, and band people early, and sometimes they call football people early. So because of all that, we decided not to quiz that day. So this is just going to have a test. So in your regular math class, you only have a test, which means we'll have a small test before then. Okay, now, the problem with that is that doesn't give you very many points. And I don't want you to end up at the end of the semester without enough points. So we will give itty bitty 1 and 2 question things throughout the next 2 weeks. Like, we'll make sure you understand it, and then we'll give you like a 1 or 2 question thing at the end of class. Not a full blown out quiz, but little bitty small assessments just to get you guys some more points. Okay, so that's this craziness going on. All right, so you have you guys offered to help your junior class with decorations or the float, because the parade is the 7th? No? Yeah, I'm a class sponsor. I have noticed that a very, very, very small portion of the school does most of the work. And then everybody else complains about how they think it doesn't look good. So, anyway, let's try another one. All right, so we're going to do this one, long division. Okay, there are certain things I want to warn you guys about. When we're doing long and synthetic division, when you notice it's missing one, like right here, do you see there is no x squared? When we notice it's missing one, when we write down the problem, I want you to put a 0 there. Okay? We're not going to let that trick us. So when we write this as division, see if I can write a straight line. closer. The divisor comes here, the dividend goes inside. But because this problem didn't have an x squared, I'm going to put 0 x squared right there. So anytime it's missing something, please put in the 0, whether it's long division or synthetic. That helps you to get these right. The other thing I would suggest, if you struggle organizing your notes, this section would be a good section to use gridded paper. I'm a big fan of the gridded paper. So that'll help you line everything up right, and it'll keep you from accidentally putting something in the wrong place. Yes, sir?
So the goal is to cancel the first two terms?
Yes, that is our goal. So let's start there. What do you multiply this by to turn it into this?
X cubed.
X cubed. So an x cubed goes here, and then we have to multiply all of this by x cubed. So that becomes, what goes here? X to the 4 plus x cubed. Okay, now we subtract. So change those signs. We're going to subtract. So this gives me negative 3 x cubed, and then I'm going to bring down the next one, plus 0 x squared. We start over. Yes, ma'am.
So when you're adding the negative x cubed and the negative x cubed, you wouldn't add the exponents?
You don't.
You don't?
When you're adding and subtracting, the exponents don't change. Very good question. When you're multiplying, the exponents change. When you're dividing, the exponents change. But when you add or subtract, the exponents don't change. So right here, since these two were both 3's and we were subtracting them, it stays the same. All right, so now what do you multiply x by to get negative 3x cubed? Negative 3x squared. So now you're thinking, what happens when I distribute negative 3x squared here? This negative 3x squared has to be multiplied times this.
Negative 3x cubed.
Negative 3x cubed and a,
Negative 3x squared.
very good. So now we subtract. Might want to change colors. Subtraction just changes your signs. All right. So when we subtract these, we're left with 3x squared. Bring down. All right, then we got to do it again. What do you multiply x by? You get 3x squared. Yes, ma'am.
How did you get 3x squared if the negative 3x cubed and the 3x cubed cancel each other out? Wouldn't it be 3x to the 4th?
Okay, so these are going to cancel, but when we're adding here, the exponents don't change when you add or subtract. When you multiply, they do, but when you add or subtract, they don't change. All right, so now we got to do a 3x times x plus 1, and that gives us 3x squared plus 3x. Oh, look at this. When we subtract, what's going to happen?
They both
They
go
both
away.
They both go away. Now, if I bring down this negative 5, that's all I got, negative 5. And I can't multiply x by anything and turn it into negative 5. Okay? So this negative 5 is the remainder. Okay, so let's write our answer. Our answer is all this stuff up top. What's another name for the answer to a division problem? Quotient. Okay? So, and then minus, because it's negative, 5 over x plus 1. Now, If you don't want to put minus, that's all right. You can write this as plus, and that is negative. That is also correct. So if you don't want to put minus right here, put it right there. All right. So that is long division. And it is long and cumbersome. Luckily, long division is not the first way we would ever pick to work a problem. The first thing I would always try to do is factor. The second thing I would try is what we're about to learn, synthetic division. And the last thing I would try is long division. I'd put that at the bottom.
Is that how we can like check our work?
You can. This just takes forever. All right. So let's do this nice shortcut. It's called synthetic division. And the cool thing is, it doesn't look like we're dividing, but we are. Okay. Alright, I'm going to do number 1 on our worksheet, and if you want to try to show it, there's not enough room. I should have given you more room. My fault. This is our problem, x squared plus 8x minus 9 divided by x plus 9. Okay. I'll go ahead and tell you, this is going to look weird, but it's so nice. It's so easy. You just have to get used to it looking weird. Alright, step 1 to synthetic division is to make sure you can do it. What we divide by has to be a binomial. If we're dividing by a trinomial, we have to do long division. Alright, so a binomial with a leading coefficient of 1. So this one works. This one works great for synthetic. Now, I start off by doing this little thing, and for some reason I call it a table. Doesn't look like a table.
Yeah.
But I call it a table. I don't know why. Alright, so I draw my little table, and on the table, I always put the opposite of this. Okay, so the opposite of this goes on the table. We always put the opposite on the table. Alright, and then what we do is we take our coefficients and our constant from our dividend. Alright, so this is an understood 1 right here. So that's going to be our first one, 1. This is a positive 8, and this is a negative 9. So we take our coefficients and our constant from our dividend, and we put it right there, beside the table. Now, next step, every time you bring down the first one. Whatever was right here, every time goes right there. Alright, and then what we do is we take the number that's sitting on the table, negative 9, and we multiply it times this. Negative 9 times 1 is negative 9. And then we add 8 and negative 9 is negative 1. Then we do it again. We take what's on the table and we multiply it times this number. And that makes positive 9. And it goes right there. And then we add. Negative 9 plus 9 is 0. Now, every time you'll see I put a little dash right here because this last one is the remainder. every time the last number you find is the remainder, which tells me this one has no remainder because the remainder is 0. Okay? Now, you work your way back. This is your constant, your plain old number. This one is your linear term, x to the first. If we had some more, the next one would be x squared, and the next one would be x cubed. So as we work the other way, we start adding in the x's. So this is the answer. X squared plus 8x minus 9 divided by x plus 9 is just x minus 1.
So if there was a remainder other than 0, you would put the remainder over the x plus 9?
Yes, sir. You sure would. Okay. So let's do number 2. We have x squared minus 3x, plus 3x minus 10 divided by x minus 2. Okay, so every time on the table is the opposite of your divisor. 2. Have we taken the opposite of something like that before? Isn't that how we got our x-intercepts? Where we took the opposite of the factor? Yeah. All right, so the 2 goes on the table, and then we bring down our coefficients. 1, 3, and our constant, negative 10. All right, we bring down the first one. Then we multiply. 2 times 1 is 2, and then we add. 3 plus 2 is 5. Yes, ma'am.
I just forgot my question. Maybe, I don't remember it.
Okay, if you think of it, let me know. Then we multiply again. 2 times 5 is 10, and then we add. Woohoo, we got another 0.
Oh, okay, I remember. Isn't 2 not a binomial? What is it for the lowest one? Because you can't.
I think you're thinking perfect squares.
Oh, okay. Never
So binomial just means it's x plus or minus.
Oh.
Alright, so this is our constant, and this one would have our x. So our answer is x plus 5.
That's
Now,
the remainder?
yeah, that does have a remainder? Yeah. Let's do number 5 next. Now, I want to talk a little bit about what it means when they don't have a remainder. What it means when they don't have a remainder is x minus 2 is a factor of this. And the quotient right here is another factor. I could have given you this same problem right here as a warm-up this morning and said, all right, class, factor this. And you would have gone, ooh, that factors to x plus 5 times x minus 2. Because 5 times negative 2 is negative 10, and 5 plus negative 2 is positive 3. So do you see how when we get a remainder of 0, both the divisor and the quotient are factors of the dividend? Okay? All right, let's jump to number 5 now. So number 5 is going to have a remainder that is not 0. We're going to have a different remainder this time. But the process is still the same. So, what goes on the table? Negative 4. Then we have to steal those coefficients and the constant. So we get 1, 5, negative 7. 1, 5, negative 7. Okay. Then every time we bring down the first one, 1, we multiply negative 4. And we add 1. We multiply negative 4. And we add, and when we add negative 7 and negative 4, we get negative 11. Negative 11 is the remainder. This one has a remainder. So when we go to write this answer, this 11 gets put over x plus 4. It's the remainder. This one is our constant, and this one has the x. Okay, so does synthetic division make sense when we have a trinomial divided by a binomial? The first ones we tried, a trinomial by a binomial, a trinomial by a binomial, a trinomial by a binomial. Okay, whoops. Yes, sir.
Can you go back to 5 real quick? Oh,
Aye.
never mind.
Yeah. You know what? I think I want to go back and do number 3 because it has a different leading coefficient. Let's go back and do number 3. What's wrong?
Never mind. That's what I did.
Okay. All right. So number 3, my dividend is 2x squared, not just x squared. That does not change our process at all. We're going to use the same process. It just means when I bring down that first one, instead of bringing down a 1, I'm going to bring down a 2. All right, so if my divisor is x minus 5, what goes on the table? Positive 5. Okay, and then I pull my coefficients. 2 and negative 7, and finally bring down the constant. Okay, so I'm going to bring down the first 2. I'm going to multiply. So this time I get 10. And then I'm going to add 3. And then I'm going to multiply. And then I'm going to add. The last one is always your remainder. So this one doesn't have a remainder. So that tells us that x minus 5 is a factor of this. What is the other factor? What does this 2 and 3 actually represent?
2x plus 3.
2x plus 3. So x minus 5 is a factor. The other factor is the quotient, which is 2x plus 3. It doesn't have to be put in parentheses. I don't know why I did. Okay. We'll go here and then here. Yes, yes.
So if you factor it first without even doing any of the division or the synthetic, what would you always get the 2 binomial, or would you?
Well, if you looked at this and you noticed that this was a factor, then it would factor to this. Sometimes they'll give us ones that do factor, but they may make the divisor something different. So we may get a trinomial that does factor, but if I don't ask you to divide by one of its factors, then you wouldn't get the factor form.
Yes, we're just going to go to the bathroom.
Okay, so now let's do some of the ones at the bottom that are a little longer and they have problems. Yes, Cole?
Can you do them too?
I can. I was actually going to start with number 7 because something's wrong with number 7. Can I start with number 7 and then do number 10?
Okay.
Alright, so I'm going to start with 7 because 7 is missing something. It is missing a 0 x. It doesn't have the 0 in for the x. So when it's missing one, you have to put in that 0. So I put a -1 on the table, but I need a 1, a -7, and the 0. If I try to do it without the 0, I'll get the wrong answer. Yes, sir.
So that's not like a grouping, like if you were going to.
Well, no, this is anytime you're doing synthetic division. Anytime you're doing synthetic division and it's the original problem is missing a term. So I looked at the exponents. It went 3, it went 2. The next exponent should be a 1. I understood 1. It was missing. So I had to put 0 x's in there. So anytime it's missing something.
So we just go to the number.
Yes, sir. Okay, so now everything's the same. Bring it down, multiply, and add, and multiply, and add, and multiply. And add. Okay, so the last one is always the remainder. So, my question to you is x plus 1 a factor of the dividend? Is this a factor of this?
No, we know it's not.
No, it's not because we didn't get 0. Okay, so now what we write as our answer is, this is our remainder part, so it has to go over the divisor. And then this is our plain old number. This one has a single x, and this one would have an x squared. So, if there's no sign in between two, it's a positive. And that's my answer.
Why is it x squared?
Okay, because we start here. This is always our remainder. Then this is the constant. This is the linear. And if we have more, then the next one would be a squared. And if we had another one, the next one would be a cubed. So we always start here and work our way back. Yes, ma'am.
So you wouldn't do anything with the x cubed?
The x cubed was represented right here. So what happens is, when we take a cube and divide it by an x, when we take a cube and divide by an x, it turns into a,
X cubed.
yeah. And that's what we did. We took a cubic polynomial and divided it by a linear polynomial. So cube divided by x is just x squared. Okay, number 10 was requested. Let's do number 10. Number 10 is 2x cubed plus 7x squared plus 2x plus 1 all divided by x minus 5. Okay, so we weren't missing any on this one. So since we're not missing any of our terms, any degrees, we don't have to put in any zeros. So what we'll do, what goes on the table? 5. And then we pick off our coefficients and our constant. And then we bring it down. And then we multiply. Right-row. These numbers are going to get big. Then we multiply. And then we add. That. And then we multiply. And then we add. And then we multiply. And then we add. Ugly.
Yeah.
Okay. So this is our ugly remainder. Now, if there's not a sign, you always put a plus. And then this is our constant. This one needs the x. And this one will have an x squared. So 2x squared plus 17x plus 87 plus 436 over x minus 5.
That's the whole remainder?
It is. It's ugly, Eric. Okay. So, is x minus 5 a factor? No. Okay. Now, on this one, negative 1, x plus 1 was not a factor. But let's go back to this one. Back to number 3. We decided that x minus 5 is a factor. Okay? Now, one cool thing that's going to happen. If we tie this back into what we did, this gives us an x-intercept, doesn't it? If we were to graph this and it factored to this times this, then 5 would be an x-intercept. So if you plug in 5 for x, you'd get out 0 for y, if we thought about this in terms of a function. Now, that is kind of a shortcut way to decide if something is a factor. Is x minus 5 a factor? If I plug in the opposite of this, and I do synthetic division, I get 0. But if I plug the opposite into the function, this is kind of cool. And you could use your calculator for this. 5 squared is 25. 25 times 2 is 50. And then 7 times 5 is 35. What is 50 minus 35? 15. What is 15 minus 15? 0. Okay, so not only do we get 0 here when we do synthetic division, we also get 0 when we plug this into the function.
Is that like the bottom?
That is like the bottom. That is what the bottom is. Now, I didn't actually even get to that part when I taught it this morning in first period. Long division took us a little while because long division was new and long and ugly. Synthetic division is really our best tool. It's quick, it's neat, there's not a ton of operations. It's just weird looking because you've never seen it before. Yeah, yes ma'am.
Can you do that method to like to solve would that always work?
If your divisor is just a binomial, then you would choose synthetic. Yes.
Like the one where like you plug in at 5.
If you plug it in, it'll tell you if it's a factor. It won't tell you what anything else is, but it'll tell you if it's a factor.
Which really isn't that hard.